Here is a number you have probably never been asked to hold in your head, 0.038. That is how strong gravity is on Mars, measured against the gravity you are sitting in right now. Not a third, not close to a third, about 38%. And I want you to sit with that number, because almost everything you have been told about humans living on Mars quietly assumes it does not matter. It matters. It might matter more than the radiation, more than the cold, more than the distance. It might be the one thing that turns the whole dream into something biology simply will not permit. I know how that sounds. Grand claim, no mechanism yet, so let me earn it. Because here is the gap I want to open up with you today. Most people believe Mars is a hard problem, a really hard problem, sure, but the kind of problem that engineering solves eventually. Build a better rocket, grow food under glass, shield the colonists from the radiation. Give it 50 years, give it 100, and we get there. That is the story, and I understand why the story feels true. We have a magnificent track record. We put a machine on the moon with less computing power than the phone in your pocket. We split the atom. We wiped out diseases that emptied whole cities. When someone says humans always find a way, they are pointing at real history, and it is a proud one. But there is a difference between a problem that is hard and a problem that is closed. A hard problem yields to cleverness. A closed problem does not, no matter how clever you are, because the thing standing in your way is not a gap in your technology. It is a fact about the universe. And I think the honest reasoning points somewhere uncomfortable. I think colonizing Mars, in the full sense of the word, might be closed, not by rockets, by biology, by a cage, that biology built around us over 3.5 billion years, and that we cannot climb out of by wanting it badly enough. That is the claim. Let us find out whether it survives. So before we go anywhere near Mars, we have to agree on how we are going to know anything, because it would be very easy for me to just assert things and for you to just nod along. And that is not how this works. Not on this channel. Here, a claim is only worth as much as the reasoning you can follow from your own armchair. So here is the rule we are going to use the whole way through. A claim earns its place only if you can see where it comes from. If I give you a number, I show you where the number was born before I lean on it. If I make a leap, I show you the ground I jumped from. And if an idea is beautiful but wrong, we say so out loud and we let it go. That last part is the hardest, and it is the most important. Letting go of a beautiful idea is a kind of grief. But it is also the only way you ever move closer to what is true. There is a word for the property that makes an idea worth trusting. Falsifiable. It means the idea makes a promise. It says, if the world is a certain way, I am wrong. And here is exactly what that would look like. An idea that can never be wrong, that bends to fit any evidence you throw at it, tells you nothing. It is not strong. It is empty. The strength of a claim is measured by how easily reality could have killed it and did not. Let me give you a quick picture of the difference, because it matters more than it sounds. Suppose I tell you the harvest failed because the spirits were angry. Good harvest? The spirits were pleased. Bad harvest? Angry again. There is no result that could ever prove me wrong. That idea explains everything and predicts nothing. Now, suppose I tell you the harvest failed because the frost came 3 weeks early, and I promise that if the frost holds off next year, the crop returns. That claim has put itself in danger. It could be killed by a single warm spring, and that danger is exactly what makes it worth something. Hold on to that, because the Mars dream is often sold to you in a form that can never be wrong. We will figure it out. Technology always finds a way. That is not an argument. That is a mood, and a mood is not falsifiable. So we are going to do something harder. We are going to ask, of every step, what would have to be true for this to work? And then we are going to check whether that thing is actually true. Here is another tool, Occam's razor. When you have two explanations, prefer the one that needs fewer new assumptions to work. It does not mean the simple answer is always right. It means you do not get to invent new miracles for free. Every time someone says Mars will work because of some future breakthrough, they are adding an assumption. and assumptions have a cost. Stack enough of them, and the argument collapses under its own weight, no matter how exciting it sounds. Picture a tower of ifs. If we invent a new engine, and if we solve closed-loop farming, and if low gravity turns out to be survivable, and if the radiation problem softens, each if is a floor built on the one below. Take away any single floor, and the whole tower falls. That is what a stack of assumptions really is, a tower with no ground under it. And I want to make that concrete because it is easy to nod at and then forget. Say each of those 4 ifs has a generous 8 in 10 chance of turning out true. 8 in 10 sounds like optimism itself, but you do not get to enjoy them one at a time. You need all 4 at once because the colony needs all 4 at once. And 8 in 10 times 8 in 10 times 8 in 10 times 8 in 10 is not 8 in 10. It is closer to 4 in 10. Chain enough hopeful things together, and the chain becomes the weakest thing about it, not the strongest. That is not pessimism. That is just how probability behaves when it is honest. And one more, orders of magnitude. This is just the habit of asking, not is this hard, but how hard, roughly, to the nearest factor of 10. Because our intuition is terrible at scale. Something that is 10 times harder feels twice as hard to us. Something 1,000 times harder just feels like a bigger version of the same thing. It is not. 1,000 times harder is often a different category of problem entirely. Keeping the orders of magnitude in front of us is how we stop fooling ourselves. Here is a small demonstration. 1,000,000 seconds is about 11.5 days. 1,000,000,000 seconds is about 32 years. Same sounding words, 1 letter apart, and the gap between them is the difference between a fortnight and a career. That is what 1 order of magnitude times 3 does to a number. Now imagine getting that wrong about a journey or a food supply or a dose of radiation. That is why we count carefully. Now, here's the part that matters most, and I want to be very clear about it. I am not a scientist. I have not done any of this research myself. I have no laboratory, no telescope, no credential of any kind. So please do not trust me because of who I am. There is nobody here to trust the reasoning, or throw it out. Every single thing I say today, you should be able to check against your own common sense and the physics you already half remember from school. If a step does not follow, catch me. That is the whole game. And there is something freeing about that. It means the argument stands or falls on its own. Not on my authority, not on anyone's, just on whether the chain holds, link by link, all the way down. If I have done my job, by the end, you will not need me at all. You will be able to rebuild the whole thing yourself from the mass of a planet and the rules of your own bones, and that is a far better place to leave you than merely convinced. So let us start building the chain, and let us start not on Mars, but on the one planet where we already know life works. Because you cannot understand why a place might be a cage until you understand the shape of the thing that built you. There is a fact about your body that you have never once thought about, and it is running right now, every second, without any effort from you. Your body knows which way is down, not your brain. Your body, every cell in your skeleton, every fluid in your inner ear, every valve in your veins, every fiber in your heart is built around a single unrelenting assumption that there is a constant pull in one direction at one strength and that it never turns off. That strength has a value. On Earth, we call it 1G. And here's the thing worth sitting with. Your biology does not treat 1G as an environment. It treats it as a law. Let me show you what I mean, because this is where the reasoning starts to bite. Think about your bones. You probably imagine your skeleton as scaffolding, fixed, built once when you were young, and then just carried around for the rest of your life. It is not. Your skeleton is a living, negotiating thing. It is constantly tearing itself down and building itself back up. And the amount it builds is decided by one question. How hard is it being loaded? Push on a bone and it thickens. Stop pushing and it dissolves the material it decides it no longer needs. Your bones are, in a very real sense, a running measurement of how hard gravity's been pulling on you lately. And that measurement is not a metaphor. It is chemistry happening in you at this moment. There are cells whose only job is to lay down new bone, and other cells whose only job is to eat it away, and the balance between them is set by load. When you stand, when you walk, when you lift a bag of shopping, you are sending a signal down through your skeleton that says, keep this, we need it. Take that signal away, and the eating cells win, not out of malice, out of thrift. Your body is the most careful accountant you will ever meet, and it does not pay to maintain a structure that nothing is asking it to hold up. You have actually felt a small version of this already. Think of a limb held in a cast for 6 weeks. When the cast comes off, the muscle has wasted and the arm looks thinner and feels weak. That happened in weeks on Earth under full gravity just from not using it. Your body pulled resources out of a part it decided was idle. Now imagine that same logic applied to your entire skeleton at once, because the whole body has concluded that the pull it was built for has vanished. Now, we already have the experiment. We did not do it on purpose, but we have the data, and it is not ambiguous. We put human beings in orbit in a place where the pull effectively drops to nothing, and we watched what their bodies did. And what their bodies did was start taking themselves apart. Bone mass gone at a rate of roughly 1 to 2% every single month. Read that again. Not per year, per month. A pace that in 1 year of weightlessness can strip away what a decade of aging does on the ground. And that loss does not come back the way you would hope. Some of it returns after a landing, slowly, over months, but not all of it. The tiny inner architecture of the bone, the delicate lattice that gives it its strength, can be lost in a way that never fully rebuilds, even years later. Which means the damage is not only a matter of how much bone, it is a matter of what kind. You can regain the weight of the material and still have a bone that is more brittle than the one you left with. That distinction matters enormously when we start talking not about a visit, but about a life. And it is not only bone. Watch the whole body follow the same logic. The heart is a muscle, and on Earth it works against gravity every beat, lifting blood up from your legs to your head. Remove the pull, and the heart has less to fight. So it does exactly what your body always does with an easy job. It shrinks the tool to fit the task. The heart actually gets smaller. The muscles in your legs, the great pillars that hold you upright all day, waste away because nothing is asking them to hold anything up. Astronauts fight this with hours of exercise strapped to machines every single day, and even then they lose ground, even then. With the best equipment ever built and a whole team on the ground watching over them, and here is a detail that ought to give the whole dream pause. The exercise does not restore full gravity. It cannot. A machine can push on your muscles for 2 hours. It cannot push on you for the other 22. It cannot load the fluid in your inner ear, or the walls of your blood vessels, or the shape of your heart while you sleep. Gravity on Earth is not a 2-hour workout. It is a 24-hour, lifelong, unbroken presence, working on every part of you at once, awake and asleep. And no schedule of exercise has ever come close to matching that. The astronauts are not solving the problem. They are slowing it down. And slowing something down is a fine strategy for a 6-month mission and a hopeless one for a permanent home. The body is not malfunctioning. That is the part people miss. The body is working perfectly. It has measured its environment, concluded that the heavy skeleton is a waste of expensive material, and begun dismantling it exactly as its rules command. The rules were written by 3.5 billion years under 1G. And the moment you break the assumption those rules were written for, the rules turn against you. So here is the turn. Everyone talks about Mars radiation, and it is real, and we will get to it. But radiation is a problem you can imagine solving. Bury the habitat, thicken the walls, add mass between the colonists and the sky. Hard, expensive, but it is engineering, and engineering bends. Gravity does not bend. You cannot thicken a wall to add gravity. You cannot bury yourself deeper to feel more pull. The 38% is not a design choice on Mars. It is a property of the planet's mass, and the planet weighs what it weighs. Someone always says, spin it, build a spinning station, and let the spin fake gravity. And on a station in space, that is a real idea worth taking seriously. But look what happened. We were talking about living on the surface of a planet, and to solve the gravity problem, we had to leave the surface of the planet and invent a spinning machine in orbit instead. That is not colonizing Mars. That is admitting the surface of Mars cannot give you what you need, and building an escape hatch from the very place you meant to settle. And a spinning colony is a whole new tower of assumptions, all its own. We came to live on the ground. The ground cannot hold us at 1G. That is the fact we keep running back into. And notice, you cannot spin the surface of a planet. The spin trick works because you are inside a sealed drum in the emptiness of space, with nothing to stand in the way of turning the whole thing. Bolt that drum to the ground, and it is just a fairground ride. And the ground under it still pulls at 0.38. And the moment anyone steps outside the drum to actually do the work of living on Mars, mine the ice, tend the crops, fix the machines, they are back in low gravity again. So the spinning fix does not fix Mars. It fixes the inside of one machine some of the time for the people not doing anything. And the whole point of a colony is the doing. Now watch the implication unfold, because this is where it stops being about astronauts and starts being about the whole dream. A colony is not a mission. A mission is a few people for a few months or years who come home and heal. We know that story. Bones recover mostly after a return to Earth. But a colony is people who never come home. It is a first generation who arrives as adults, already built by 1G, now living in 0.38, and it is a second generation who is never built by 1G at all. Think about what that second generation actually is. A child conceived on Mars, grown in a womb under a third of Earth's pull, whose bones and heart and inner ear form for the very first time under a law their species has never once experienced. Think about how much of your body was assembled by gravity, working on it while you grew. The way your spine stacked itself into a column strong enough to carry your head upright, the way the tiny stones in your inner ear settled so you could tell up from down and not fall over. The way your heart learned exactly how hard to push to reach your brain. All of that was tuned in the womb and in childhood against 1G. There is no recovery for a Mars child because there is no baseline to recover to. They are not damaged earthlings. They are something the reasoning cannot yet name, built to specifications no biology on this planet has ever been asked to meet. And it goes deeper than bone and blood, into the very beginning of a life. Before you were a baby, you were a single cell dividing, and then a hollow ball of cells folding itself into a body, and the direction of that folding, the sorting of top from bottom and front from back, unfolds inside a world that has a down. Every cell in that early process is swimming in fluids that settle, sitting under a weight, oriented by a pull that has never once flickered off in the entire history of animal development. We do not know how much of that earliest choreography leans on gravity. We have never watched it happen under anything else. And that is not a small gap in our knowledge. It sits at the exact foundation of making a new person, and we are proposing to move it to a world where the one constant it has always had is cut to a third. And here is the honest edge of it. We do not know what happens. We have never grown a mammal from conception to adulthood in low gravity, not once. That experiment has never been run, which means everyone who tells you a Mars child will be fine is not reasoning. They are hoping. And everyone who tells you it will be a catastrophe is doing the same thing in the other direction. The truthful position is narrower and more interesting. We are about to break the single deepest assumption in the entire history of life, and we have no idea what breaks with it. But there is something almost nobody sees here. Notice that the problem is not the trip, the problem is staying. Everything gets worse the longer you stay and the younger you were when the clock started. That is the exact opposite of an engineering problem, which usually gets easier as you learn. This gets harder as you commit. The cage is not at the door. The cage is inside. Let me take you somewhere else entirely. Because the gravity argument is only the first wall, and on its own you might reasonably say, well, maybe biology adapts, maybe we are tougher than we think. Fine, let us grant it. Let us pretend the bones hold and the Mars children grow up strong. There is a second wall, and this one has nothing to do with strength. It has to do with poison, and with a fact about the ground itself that no amount of adaptation touches. Here is the assertion. Mars is not empty. Mars is actively hostile at the chemical level, and the very dust it is made of is a slow toxin. Walk it through with me. On Earth, dirt is alive. A handful of ordinary soil is a teeming city of microbes, fungi, and the broken down remains of 1 billion years of life. And that living network is what feeds plants, what recycles waste, what holds the whole system in balance. Take a moment on that. In a single handful of good garden soil, there are more living organisms than there are human beings on the entire planet. That is not scaffolding for plants. That is a whole civilization of the very small doing chemistry for you, for free, without a thought. It pulls nitrogen out of the air and hands it to roots. It breaks down what dies and turns it back into food for what lives. It holds water. It builds structure. Not one of those services comes with a bill, and not one of them exists on Mars. That is not what covers Mars. What covers Mars is called regolith. And regolith is not soil. It is shattered rock and dust, sterile, and shot through with compounds called perchlorates. Now, I told you I would explain any term the moment it appears. Perchlorates are a kind of chemical salt. And here is the part that matters. In the right dose, they interfere with the human thyroid, the gland that runs your metabolism. And they are toxic to the body in ways that build up over time. So the first thing you would want to do on Mars, grow food in the ground, run straight into this. The ground is poison. Not dramatically, not instantly, slowly. Which is worse, because slow poison is the kind you do not notice until the damage is done. And it is not a trace. On parts of Mars, the perchlorate content of the surface material is measured not in the tiny fractions we would tolerate in drinking water on Earth, but in whole percentage points of the soil. You would have to wash the ground itself before you could even think about growing in it, and washing it means water, and water on Mars is its own long, expensive war. And washing does not make the problem vanish. It moves it. Rinse the perchlorate out of the soil, and it is now in the water you rinsed it with. So now you have poisoned water to deal with on a world where every drop of water is scarce and precious and cannot simply be poured away. And the perchlorate is only the headline. The regolith is also laced with fine grains of certain metals in forms that are hard on the body, and it has never once been weathered by rain or life the way every scrap of Earth's soil has, softened and rounded and made safe over ages. Mars dirt is sharp in ways. Earth dirt stopped being long before there were lungs to breathe it. So even the cleaned version of the ground is a compromise, a thing you have made barely tolerable at great cost, not a thing that was ever meant to grow food. But hold on, someone says. We will not use the ground. We will grow everything hydroponically, in sealed water systems, indoors. Good. Reasonable. Now count the assumptions you just added. You need enclosed growing space sealed against a near vacuum at a scale that feeds every mouth every day forever, with zero crop failures you cannot recover from, powered by an energy supply that never dips below the line where people starve. And think about the scale, honestly. Feeding one adult by farming is not a window box. It is something closer to a small field's worth of continuous, healthy, productive, growing, running without a break. Multiply that by every colonist. Now enclose all of it, pressurize all of it, light all of it, heat all of it, and keep it that way through dust storms that can dim the sky for weeks. On Earth, if your greenhouse fails, you buy food from the next farm over. On Mars, there is no next farm. There is the vacuum, and then there is nothing for the better part of 100 million kilometers. And that pressurized greenhouse is fighting the sky itself the entire time. Mars has almost no air. The pressure outside is less than 1% of what you are breathing right now, so close to a vacuum that your sealed dome is not really a greenhouse at all. It is a balloon holding a whole atmosphere of pressure trying to burst outward into nothing. Every seam, every seal, every pane is under that constant strain, day and night, year after year. And the plants inside need a specific mix of gases to breathe, a specific warmth, specific light, all manufactured, all monitored, all replaced when it leaks, which it will, because everything leaks eventually. On Earth, a hole in the greenhouse glass is a chilly night and a note to fix it. On Mars, a hole in the dome is a countdown. And now bring back the dust, because the dust does not stay outside. Martian dust is fine, far finer than sand, closer to smoke or talcum powder, electrostatically charged so it clings to everything, and shaped in ways that make it abrasive to lungs and machinery alike. Every time an airlock cycles, sun comes in, it rides in on the suits, it settles in the seams, it coats the solar panels and cuts your power a little more each day. It grinds at every seal and every joint. It is the kind of relentless, patient adversary that does not need to win any single battle. It just needs you to be there long enough. And there is a cruel echo here, because the dust is made of the same regolith, carrying the same perchlorates, so the thing coating your equipment and drifting into your air is also mildly poisonous. The poison and the grit are the same enemy, wearing the same gray coat everywhere, always. We have actually watched the dust win in a small way already. Machines we sent to Mars, running on sunlight, have slowly starved as dust piled onto their panels and choked off their power until they fell silent. Not destroyed by some dramatic accident, just quietly buried a little more each day by a planet that never stops shedding its gray powder into the wind. Now picture that same patient burial working against a colony that cannot afford to go dark, that needs its power to make the air and warm the rooms and light the crops, and you begin to see the shape of the thing. On Mars, keeping the dust off is not housekeeping. It is survival, done by hand, forever. Here is the turn for this one. The threat on Mars is not the dramatic disaster. It is the accumulation. It is 1,000 tiny margins, each one survivable alone, all grinding in the same direction at once. The perchlorate in the dust in the lungs, the dust on the panels feeding the greenhouse feeding the people. Every link in that chain has to hold, not for a mission, but for generations. And the arithmetic of reliability is brutal here. If any one link has even a small chance of failing in a given year, then over enough years, failure is not a risk, it is a certainty. That is just how probability stacks. A 1 in 100 chance each year sounds tiny, but run it across 100 years, and the chance that it has happened at least once climbs to nearly 2 in 3. Add up a dozen such links, each with its own small annual chance, and you are no longer asking whether something fails. You are asking only when and whether you can fix it before it kills you, every time, forever. And on Earth, we hide from that arithmetic by having spares. A part fails, you swap it. A crop dies, you buy from elsewhere. A person gets sick, another does the job. Redundancy is the quiet reason our own lives feel so stable. Every critical thing has a backup, and the backup has a backup, and most of it we never even see. On Mars, every spare is either something you carried across 100 million kilometers at ruinous cost, or something you must manufacture on site from a planet that gives you nothing freely. The colony that runs out of a critical part does not get to order another. It waits for the next launch window, which may be 2 years away, and hopes the failure was not the fatal kind. Thin margins, no spares, and a clock that never stops. That is the true face of the second wall. Compare that to Earth for a moment, and let the contrast do the work. You are, right now, inside a life support system so vast and so self-repairing that you never think about it. The air remakes itself. The water cycles through the sky, falls as rain, runs to the sea, rises again, clean, without a single pump you own. The temperature holds inside a band your body can survive without a valve you have to maintain. Trillions of organisms are running your planet's chemistry for free, and they have been doing it without a break for longer than there have been animals. That is not a habitat we built. That is a habitat that built us. And on Mars, You have to become the engineer of every single one of those functions forever with your own hands and never once get it wrong for long. Every breath of air is now a manufacturing decision. Every drop of water is now inventory. Every degree of warmth is a power bill paid in sunlight fighting through the dust. But there is something almost nobody sees here, and it is the deepest part. When people picture a Mars colony, they picture a frontier town. A hard place, but a place. Log cabins and a general store, only under a dome. What the reasoning actually describes is closer to a single, enormous, permanently failing machine, in which the humans are not settlers but maintenance staff who can never clock off on a planet that is not neutral toward them but chemically corrosive to them, on ground that is not merely lifeless but mildly poisonous to the touch. The frontier settlers of history walked into land that already had air, water, soil, and other life. Every one of those was already there, for free. The hardest desert any human has ever crossed still had breathable air overhead, and the same gravity underfoot, and somewhere water that fell from the sky. On Mars, not one of them is, that is not a new home. That is a cell with a very good view. Now I want to attack the dream at its strongest point, because so far you might be thinking, all right, the surface is bad, the gravity is low, but these are problems of a place. Change the place or change the technology, and maybe you escape. So let us grant the wildest optimism. Let us say we solve the surface completely. There is still a third wall. And this one is not about Mars at all. It is about the road to Mars. And it is written not in biology or chemistry, but in the plainest arithmetic there is. Here is the assertion. The distances involved are not large. They are absurd. And the numbers do something to the human body that we have already measured and cannot fix. Let me build the scale from the ground up, because this is exactly the place our intuition betrays us. You know what a kilometer is. You can walk one in about 10 minutes. The moon, the farthest any human being has ever traveled, sits about 380,000 kilometers away. Far. If you could drive there in a car at highway speed without stopping, it would take about 6 months. But we did it faster, in 3 days, with a rocket. Now Mars. When Mars is at its closest, its very closest, on the best alignment we get, it sits about 55 million kilometers away. When it is on the far side of its orbit, it is more like 400 million. So the nearest neighbor we dream of settling is at its friendliest more than 140 times farther than the moon. Put it another way, if the moon is a 3-day drive, the same journey to Mars at that friendliest alignment is over a year of the same driving without stopping, and Mars refuses to sit still while you do it. Let me stretch that scale once more, because it is worth feeling. If you shrank the whole thing down until the Earth and the moon were a single step apart, the length of one ordinary pace, then Mars, at its closest, would be well over 100 paces away. More than the length of a football pitch. And that is the good day, the closest it ever comes. On a bad day, it is the length of several pitches. The moon we reached in 3 days is one step. Mars is across the field. And that is still, remember, the very nearest world we could ever dream of reaching. Everything else is in another town, another country, another continent of the mind. That is why the trip is not measured in days. It is measured in months. 6 to 9 months out, on a good trajectory dictated by orbital mechanics, which is just the unbreakable rule book of how objects move under gravity. You do not point at Mars and fire. You cannot. Mars is moving fast along its own orbit around the sun, and so are you. You have to throw yourself along a long curving arc and meet the planet where it will be months from now, like a hunter leading a running target, except the target is a world and the lead time is half a year. The rule book does not negotiate. Then you wait, because Earth and Mars only line up favorably about every 26 months. You cannot simply turn around and come home when you like. You arrive, and then the door to the return trip is locked for well over a year until the two worlds swing back into position. Then 6 to 9 months back, the shortest serious round trip anyone plans, with the wait built in, is measured in years. And think about what that lock really means for a person. It is not just an inconvenience, it is the removal of the single thing that makes every dangerous place on Earth survivable, which is the option to leave the deepest submarine, the loneliest research base at the bottom of the world, the highest mountain camp. All of them share one mercy. If it goes truly wrong, there is a way out. A slow one, a hard one, but a way. On Mars, for well over a year at a stretch, there is no way out. Someone falls gravely ill, a system fails past repair, the food runs short, and the answer is the same: wait for the window. The universe has locked the door and will not open it early for any emergency you can name. No frontier in human history has ever been that final. Now bring back the body. Remember what we established about bone loss in weightlessness: 1 to 2% a month. Do the multiplication for a 9-month transit. That is a serious fraction of a skeleton gone before your boots ever touch the ground. And bone is only the headline. The heart, freed from having to pump against gravity, weakens and reshapes. The fluids in your body no longer pull down, drift upward and pool in your head and press behind your eyes. And vision changes, sometimes permanently. Astronauts have come home needing stronger glasses than they left with. And some of the change did not reverse. The immune system falters. And over all of it, the whole way, something you cannot shield against on that road: radiation. On Earth, you are protected by two things you never see and never think: a magnetic field wrapped around the whole planet, invisible, enormous, deflecting the storm of charged particles the sun throws at us, and above that, a thick blanket of atmosphere, tens of kilometers deep, soaking up what the magnetic field lets through. Between them, they turn a lethal sky into a mild one. You have lived your entire life at the bottom of that double shield and never felt a thing. In transit to Mars, you have neither. You are a soft body in a thin metal can, crossing the open ocean of space for the better part of a year, absorbing a dose that climbs and climbs with no shore in sight. There are two kinds coming at you: the steady drizzle from deep space and the sudden violent bursts when the sun flares, which can arrive with almost no warning and deliver in hours what the drizzle delivers in weeks. And notice the trap inside the radiation problem, because it is the same trap as everything else. The obvious answer is to add shielding thick walls of material between the crew and the sky. But shielding is mass. And mass is the one thing a rocket cannot afford. To carry a heavy shield, you need more fuel. And to carry that fuel, you need more fuel to lift it. And the wall you wanted to build to protect the crew makes the ship you can actually launch smaller and slower and worse. So you are caught. Shield them properly and you cannot get off the ground. Get off the ground and you cannot shield them properly. The problem and the solution are pulling on the same rope in opposite directions. And the rope is the merciless arithmetic of what a rocket can lift. And here is the cruel geometry of it. You cannot go faster to reduce the exposure, not by much, because going faster means carrying more fuel, and more fuel means more mass, and more mass means you need still more fuel to move that fuel, and to move that fuel, you need more fuel again. That spiral is real. It has a name in the arithmetic of rockets, and it is why the trip cannot simply be shortened by strapping on a bigger engine. Every extra kilogram of speed fights you. There is a reason we speak of escape velocity, the sheer speed you must reach just to climb up out of a world's gravity in the first place. And it is not a small number. Getting off Earth at all is already a colossal expense paid before the real journey has even begun. Here is the turn. We treat the journey as a preliminary, a thing you get through to reach the real challenge, which is the surface. But the reasoning says the opposite. The journey is not the preamble to the danger. The journey is the danger, delivered in a form no wall can stop, to a body that arrives already weakened at the exact moment it needs to be strongest, on a world that then demands it survive under 1/3 of the gravity it was already losing on the way. Let me put a thought experiment on it, because I think it makes the scale of the thing land. Imagine the light speed limit, the hard ceiling of the universe. the fastest anything can ever go. A beam of light crosses from the Earth to the moon in about a second and a bit. It reaches Mars at the good alignment in a few minutes. Now imagine you could travel not at light speed, but at the very best speed our fastest spacecraft have ever reached, which is a tiny fraction of it. At that speed, the nearest star beyond our own sun, just the single nearest one, would take you tens of thousands of years to reach. Longer than all of recorded human history, several times over, one way. Mars is nothing next to that. Mars is next door. Mars is the corner shop. And Mars, the easy one, the neighbor, already breaks the body over a 9-month drive. Sit with what that tells you about everything beyond it. And this is why the language of the cosmos is honest in a way our dreams are not. Out there, distance and time are the same currency. To ask how far is to ask how long. And there is no way to spend less of one without spending more of the other, because the light speed limit caps the exchange rate, and no cleverness has ever moved it. A light year is not a measure of space. It is a measure of patience. When you hear that some star is 40 light years away, you are being told that 40 years of a human life is the very fastest a message could make the trip, and only if it were made of light and nothing slowed it. We are soft and slow and mortal, and the universe charges in a currency we can barely afford to spend, even reaching the house next door, because there is something almost nobody sees here. The distance to Mars is the smallest interstellar scale number a human will ever confront, and it is already too big for our biology. We are not held back from the stars by a lack of ambition or engineering. We are held back by the fact that we are made of soft, gravity-shaped, radiation-vulnerable matter. And the currency of space is distance, and distance is paid in time, and time is exactly the thing that dismantles a human body when you take away the ground it was built on. Distance and time are the same currency out there, and the body cannot afford the exchange, even for the nearest fare. So we have 3 walls, and I want to bring them together now, because separately, each one is merely daunting, and daunting things get solved all the time. But look at them together and something changes. They are not 3 problems, they are 3 faces of one problem. The gravity wall says your body is a measurement of 1g, and Mars is not 1g, and there is nothing you can do to the planet to make it 1g. The poison wall says the ground itself is against you, and the air must be manufactured, and every life function Earth performs for free must be performed by hand, forever, without a break long enough to be fatal. The distance wall says the road there is a slow injury you cannot shield and cannot shorten, and that this smallest of cosmic distances already exceeds what a human body can spend. Now, here is what they have in common, and it is the whole point. Every one of these walls is a place where biology meets a fact of the universe that does not bend. Not a fact about our current tools, a fact about mass, about chemistry, about the speed of light, about the distances between worlds, and that is a completely different kind of obstacle from the ones we are used to beating. Think about how we normally win. We won flight because air can be pushed against, and we found the shape that pushes it best. The air was always willing. We just had to learn the shape. We won many diseases because bodies follow rules, and we learned to read the rules and intervene at the right point. In every case, the thing standing in our way was ignorance. And ignorance is the one enemy that reliably retreats. Push on ignorance, and it gives every time a little more each generation. But gravity on Mars is not ignorance. We understand it completely. We can predict it to more decimal places than we will ever need. Understanding it more does not make it stronger, and it does not make it weaker either. It just sits there at 0.38, unmoved by how much we know. The distance to Mars is not a mystery we might one day solve. We know it to the kilometer, minute by minute, years in advance. Knowing it better does not make it shorter by a single step. And this is the exact place where the story we tell ourselves goes wrong. So let me name the mistake as plainly as I can. We look back at every wall our ancestors faced, the ocean, the sky, the diseases, the atom, and we notice that every one of them fell. And from that, we draw a rule. Walls fall. Always keep pushing. But that rule quietly hides the thing that actually mattered. which is that every one of those walls was made of the same stuff: ignorance. They fell not because we pushed, but because they were the kind of wall that pushing works on. We are so used to that kind of wall that we have forgotten there is any other kind. And then we walk up to a wall made of the mass of a planet, and we push, and we are astonished that it does not move. And instead of asking whether it is a different kind of wall, we simply push harder and promise ourselves it will fall next century. That is not confidence. That is a failure to check what the wall is made of. This is the trap in the whole cultural story of Mars. We take the fact that we have solved hard things before, and we quietly assume every hard thing is the same kind of hard. But the hard things we solved were hard because we did not yet understand them. The moment we understood, the wall turned out to be a door. These walls are hard precisely because we do understand them, and understanding shows us that the barrier is not in our knowledge. It is in the constants, and you cannot out-engineer a constant. You can only build inside the space it leaves you. Engineering is the art of arranging the world's constants to your advantage. It has never once been the art of repealing them. Let me say the uncomfortable thing plainly, and then let me immediately be honest about its edges. A colony, a true self-sustaining human society that lives and reproduces and continues on Mars without Earth, might simply be one of those things the universe does not permit for a creature shaped like us. Not because we are not clever enough, because we are Earth-shaped all the way down, in our bones, in our blood, in the very chemistry of our cells, and Mars is not Earth, and the difference is not a bug to be patched. It is a wall built out of the mass of a planet, the chemistry of its dust, and the width of the dark between the two worlds. And notice what kind of claim that is. It is falsifiable. That is the honest test, the one we set for ourselves at the start. This whole argument makes a promise. It says, grow a healthy mammal from conception to adulthood under 1/3 of Earth's gravity and let it reproduce healthy young of its own. And I am wrong. Manufacture a closed life support loop that runs for a full generation with no fatal failure, feeding and breathing and watering a real population with no resupply from Earth, and I am weaker. Find a way to carry a soft body across that dark ocean without slow ruin, shielded and swift, and the third wall falls. The argument is not a mood. It is not, we will never do it because I say so. It is, here is exactly what would have to be true, and here is why each one runs into a constant rather than a gap. That is the difference between reasoning and a feeling, and I want you to hold me to it. Bring me the mammal that grew up strong under 1/3 of a G, and I will retire the whole argument on the spot, and gladly. There is a principle we have not named yet, and it belongs right here. The mediocrity assumption, sometimes called the Copernican principle. It is the humble idea that we are probably not special, not located at the center of anything, not the exception to the universe's rules. We used to think Earth was the center of everything, with the sun and stars wheeling around it for our benefit. It is not. We are on an ordinary planet, around an ordinary star, in an ordinary corner of an ordinary galaxy, and that same humility, turned on ourselves, suggests something the Mars dream refuses to hear. That we are probably not the exception to biology either. That a creature this precisely fitted to one planet is probably not, by some lucky accident, also fitted to survive everywhere. The odds were never in favor of us being universal. Think of a deep-sea fish, built for crushing pressure and endless dark. It is a marvel, perfectly made, and it cannot survive 1 meter onto dry land. We do not call that a failure of the fish. We call it a fit. We are that fish. Earth is our pressure and our dark. The odds favor us being local, beautifully, thoroughly local. And there is a strange comfort in laying it beside the great question of whether anyone else is out there at all. We look at the sky and we count the exoplanets, the worlds around other stars, and we hunt for a Goldilocks zone, the narrow band around a star where a planet is neither too hot nor too cold for liquid water. We search those worlds for a biosignature, a chemical fingerprint of life, or a technosignature, some sign that a mind has been at work. And under all of that searching sits the same quiet lesson we have been circling. Life, if it is out there, will be fitted to where it arose, as precisely and as locally as we are fitted to here. A creature born under some other star's gravity, breathing some other air, would find our green and gentle earth as lethal as we would find their world. The fit runs both ways. Everyone, everywhere, is probably a prisoner of the place that made them. And that is not a tragedy. That is simply what it means to be alive somewhere in particular. That is the convergence. 3 walls, 1 shape, a soft, earth-made body, meeting the unbendable arithmetic of mass and distance and chemistry on a world that owes it nothing. So let us bring it home. Let us go back to where we started, because I think the journey has changed what the beginning means. We started with a number, 0.038, 38%. And I asked you to sit with it, and I promised you it might matter more than anything else. Now you can see why. That number is not a detail. It is the first crack in a wall that runs all the way through the dream. We began by agreeing on how to know things, that a claim is only worth as much as the reasoning you can follow yourself, that the strongest ideas are the ones that dare to be wrong in a specific way, the ones that are falsifiable, that put themselves in danger and survive, that we do not get to invent miracles for free because of Occam's razor, and that stacking ifs builds a tower with no ground under it, and that our intuition lies to us about scale, which is why we count in orders of magnitude, why 1,000,000 and 1,000,000,000 are worlds apart even though they rhyme. And I told you not to trust me, but to trust the chain, and to break it if it does not hold. That offer still stands, every link of it. Then we walk the first wall. Your body is not a passenger in gravity, it is a measurement of it. Your bones build themselves to match the pull, and in weightlessness they dissolve at 1 to 2% a month, and your heart shrinks and your muscles waste, not because the body is broken, but because it is working perfectly, obeying rules written across 3.5 billion years under 1G. And Mars is not 1G. You cannot bury yourself deeper to feel more gravity. You cannot thicken a wall to add it. The problem is not at the door. It is inside every cell. And it is worst of all for a child who is built for the very first time under a law our species has never lived beneath, with no baseline left to recover to. Then the second wall. Mars is not empty and neutral. It is chemically hostile. The ground is regolith laced with perchlorates, a slow poison, measured in whole percentage points of the soil, and the dust that carries it is fine as smoke and clinging and abrasive, cutting your power and grinding your seals and drifting into your lungs. Every life function that Earth performs for you invisibly and for free, air, water, warmth, you must perform by hand forever. And the arithmetic of reliability says that a small chance of failure each year becomes a certainty across a lifetime. No spares that you did not carry or build. No door to leave through when it goes wrong. Not a frontier town with air and soil already waiting. A permanently failing machine you can never stop tending. Then the third wall. The distances are not large, they are absurd, and they are the smallest such distances we will ever face. 55 million kilometers at the very best, usually far more, 6 to 9 months each way, dictated by orbital mechanics that do not negotiate, with the return door locked for over a year once you arrive. And the whole way, the body loses bone and heart and vision, soaked in radiation you cannot shield and cannot outrun, because going faster costs fuel, and fuel costs mass, and mass costs more fuel in a spiral that fights every kilometer. You arrive weakened onto a world that demands you be strong. The journey is not the preamble to the danger. The journey is the danger. And then we put the 3 together and found there were one thing wearing 3 faces. Every wall is a place where a soft, earth-shaped body meets a fact of the universe that does not bend. Not ignorance, which retreats when you push on it, constants, which do not, mass, chemistry. The speed of light, the width of the dark. You cannot out-engineer a constant. You can only build inside the room it leaves you. And the Copernican principle whispers the rest. We are probably not the universe's exception. We are almost certainly its local, gorgeous, specific case. The fish that cannot leave the deep. Made here, fitted here, home here. Now, I have to be honest with you, because this whole thing falls apart the moment I pretend to more certainty than the reasoning earns. And it has not earned certainty. It has earned a strong, bounded doubt. And those are not the same thing at all. Here is what is genuinely open. We have never run the experiment that would settle the gravity question. Not once. No mammal has ever been grown from conception to adulthood under low gravity. Not on Mars, not on the moon, not on a spinning machine built to fake it. It is possible, it is genuinely possible, that a third of a G is enough. That there is a threshold somewhere below 1 G and above 0. A line where bodies still form well enough to live and reproduce. And that Mars happens to sit on the right side of it. We simply do not know where that line is, or whether it exists at all. Anyone who tells you they know, in either direction, has left the reasoning behind and started guessing in a confident voice. The truthful answer is that the boundary is real, and we have not yet found where it sits. That is not a weakness in the argument. That is the argument being honest about its own edge. And the walls are not equal, and I should say so. The distance wall could soften with better propulsion, not to nothing, but somewhat. A faster ship shortens the exposure. The poison wall is engineering. Brutal and endless, but engineering. And engineering does sometimes surprise us in ways we could not have named in advance. It is really the gravity wall and the child born under it that turns a hard problem into a possibly closed one. That is the load-bearing wall of the whole argument. Everything heaviest rests on it. Push there, and if it holds, I am right. If a Mars child can grow up strong and whole and go on to have strong, whole children of their own, then I am wrong, and gladly so, because I would love to be wrong about this. Truly, that is what the open question means. It means the door is not proven shut. It is only on the reasoning we have in hand today, very heavy, and everything we know so far says we are pushing the wrong way. And there is a way to find out that costs no lives and needs no colony. Grow the mammals first. Under low gravity, in a spinning machine near Earth where they can be watched and helped, and if it goes wrong, brought home. Let a generation of them be born and grow and have young of their own before we ever send a single human family to bet their children on a guess. That is what the honest version of this dream looks like. Not a bold leap onto the surface with our fingers crossed, but a patient, falsifiable question asked carefully of the one wall that decides everything. If the answer comes back yes, I will help pack the ship. If it comes back no, then we will have learned the most important thing there is to know about our own place in the universe, and learned it without burying anyone to find it out. So let me leave you not with an answer, but with the thing that started all of this. Wonder, because here is what stuns me, and I mean it. The very same reasoning that seems to close the door on Mars swings open a much larger one. If we are this precisely fitted to this one world, if the fit runs all the way down into the chemistry of our blood and the calcium in our bones, then Earth is not a starting line we are impatient to leave. Earth is the rarest thing the reasoning has turned up all day. A place that does the impossible work for free. A place that built you to match it so exactly that you never once noticed the gift. Every breath already filtered and mixed to the right recipe. Every drop of water already lifted to the sky and cleaned and handed back as rain. 1G, holding your bones together while you slept every night of your life without a single valve you had to check or a single bill you had to pay. That is the cage biology built around us. And I have called it a cage the whole way through because from the inside, a fit that tight can feel like walls. But turn it over in the light. A cage keeps you in against your will? This thing keeps you alive without your effort. It is the reason there is a you at all to sit here and dream of other worlds. And there is something almost unbearably beautiful in that. That the same fit which may keep us from Mars is the exact fit that gave us the eyes to look at Mars in the first place, the brain to work out how far it is, the heart to want to go. We are not trapped on Earth, we are made of Earth. Those are very different sentences, and the whole cosmic perspective lives in the gap between them. We do not know yet where the boundary sits. That is the honest end of it, and it is a good end, a better end than any tidy answer, because it means the universe still has something to tell us that we cannot yet guess. Maybe the wall gives, maybe a child under a third of a G grows up strong, and we all get to be joyfully, publicly wrong together, and I will cheer louder than anyone. I hope so, but whatever the answer turns out to be, the fact that you can follow the reasoning this far, that you can hold the mass of a planet and the width of the dark and the quiet rules of your own bones inside a single thought from your own armchair with no credential and no telescope, only your attention and your willingness to check each step. That is the thing I find genuinely thrilling. That is scientific literacy. Not knowing all the answers, knowing how to walk toward them, one honest step at a time, and knowing exactly how far the boundary sits and how much is still dark beyond it. Thank you for spending this time with me. Really, there are 1,000 things you could have done with the last while, and you chose to sit with a hard, strange, open question and follow it all the way to its uncomfortable, beautiful end. That is rarer than you think, and I do not take it lightly. If this is the kind of thinking you want more of, the slow kind, the honest kind, the kind that treats you as fully capable of following any argument laid out with care, then I would be glad to have you subscribe and come back for the next one. No rush, no pressure, just an open door, and the next question waiting quietly behind it. Until then, keep looking up and keep asking how you know.